Hello friends, in this video we are going to study about basics of 16-bit 8086 processor. So before going through the architecture of this 8086, let's see what do you mean by a processor or a microprocessor. So there can be some definition of this processor, but I can say that this microprocessor or a processor is a small chip that resides in computers and other electronic devices. Their job is to receive input and provide the appropriate output. So I hope you got the idea about this processor, right? So every computer or any electronic device has a small chip on which we give some input and we generate some output depending on our needs. So let's see the architecture of this 8086. This is the block diagram of this 8086. It is divided into two functional parts. The upper part is known as bus interface unit and the lower part is known as the execution unit. If you observe it properly, this whole architecture or this whole blocks are connected to your memory, right? From memory, you will be fetching the instructions one by one, and these instructions we will be storing it in some registers after operations, depending on what type of instruction you have given in the code. So basically we have all the 4 segment registers here. ES stands for extra segment, CS stands for code segment, SS stands for stack segment, DS stands for data segment, and IP stands for instruction pointer. We have an instruction queue, right? So this memory interface and instruction queue has been connected with the bus, right? So at a time, 6 instructions can be fetched in this instruction queue. So this queue is known as instruction stream byte queue, right? In execution unit, we have general purpose registers. The size of each general purpose register is 16 bits. Even the size of segment registers and instruction pointer is of 16 bit. Now this 16 bit is divided into 8 bits, right? So the lower part of the 16-bit register is known as AL and the higher part is known as AH, right? So this A stands for AL or AH. It totally combined becomes a AX register which is of 16 bits. So AX stands for accumulator. BX is again divided into 8 bits. So this BX totally is known as a base register. CX is known as counter register. DX is known as data register, right? After that we have a stack pointer, base pointer, source index and destination index, each of 16 bits. These are not divided into 8 bits, right? Then we have a control system, we have a arithmetic logic unit, we have some operands and flags. So let's see this architecture in detail. Now, why it is called as a 16-bit? The term 16-bit means that its arithmetic logic unit, internal registers and most of its instructions are designed to work for 16-bit binary words. This 8086 has a 16-bit data bus and a 20-bit address bus. The data bus carries the data from one register to another register, right? So either you can send a data of 8-bit or you can send a data of 16-bit, right? Now this address bus carries the addresses of the memory locations, right? Now these addresses are of 20-bit. Words will be stored in two consecutive memory locations. If the first byte of the word is at an even address, then the 8086 can read the entire word in one operation itself. And if the first byte of the word is at an odd address, the 8086 will read the first byte in one operation and the second byte in another operation. So for odd address, we need two steps or two operations to be done. Just now in the diagram I shown you the two blocks, functional independent units of 8086 CPU, that is bus interface unit and execution unit. So let's start with the bus interface unit. This unit handles all data and addresses on the buses for the execution, such as it sends out addresses, fetches the instructions from memory, read data from ports and memory, as well as write data to the ports and memory, right? So read means fetching the data from ports and memory, and write means put the data into the port and the memory, right? So the function of BIU, that is bus interface unit, is to fetch the instruction or data from the memory, write the data to the memory, write the data to the port, and read data from the port. Instruction queue. Why this instruction queue is used? It is used to increase the execution speed. BIU fetches as many as 6 instruction bytes ahead to time from memory. The prefetch instruction bytes are held for the execution unit in a first in first out group, that is FIFO manner, that is queue. Therefore it is known as a queue. And this first in first out group of registers is called as instruction queue, right? So when the execution unit is ready for its next instruction, it simply reads the instruction from this instruction queue one by one. So this is much faster than sending out an address to the system memory and send back the next instruction byte, right? So why we are using this instruction queue? Instead of always going to memory and fetch the data, it takes a lots of time. So what we are doing, the 6 bytes of instructions, we are storing it in the queue, and one by one we are giving it to the execution unit, right? The next is your fetching the next instruction while the current instruction executes is called a pipelining. If suppose in EU one of the instruction is executing, but the 6 bytes of instruction which has been fetched in instruction queue, they are in a pipeline manner. So therefore it is known as a pipelining. One instruction is executing but others still are being fetched so that it will become the next instruction. So in this way, this instruction execution is known as a pipelining. Now let's see the segment registers. It has 4 segment registers which are of size 16-bit. First one is extra segment register, code segment register, data segment register, stack segment register. So these segment registers are used to hold the upper 16 bits of the starting address for each of the segments. The part of the segment starting address stored in a segment register is often called as the segment base, right? See, all the 4 segment registers are used to store something, right? So the upper part of this segment, whatever the address will be having, that address will be the base address of that segment. This code segment has the register known as CS register, that is code segment register, is used for addressing a memory location in the code segment of the memory where the executable program is stored. See, whatever the assembly code you are going to write, it is stored in the code segment. Okay, so this code segment is a part of the memory. Memory is divided into 4 segments: code segment, data segment, stack, and extra segment, right? So in these segments we will be storing the data, right? So in code segment we store the actual assembly code, right? Data segment. The data segment contains most data used by the program. So the data are accessed in the data segment by an offset address or the content of other register that holds the offset address. So what we are doing in this data segment, we are storing the offset address or the content of other registers. Okay. Next is the stack segment. In this stack segment, we define a section of memory to store addresses and data while a subprogram executes. Suppose there are some functions present in your assembly code. These functions are known as subprograms, right? So after executing that function, we should jump to the main program. So from where it has been started and where it has been ended, that end and start address should be stored in the stack segment, right? Next is the extra segment. This is an additional data segment that is used by some of the string to hold the extra destination data. Basically, we are going to use this extra segment in one of our assignment related to the string operations. That means whenever you are taking the input from the user as a strings, then you will be using a extra segment. The next in BIU we have seen the instruction pointer, again which is of 16-bit, right? So this holds the 16-bit address of the next code byte within this code segment, right? Memory is divided into 4 segments. In that we have a code segment. In code we are having all our assembly code. So that code should be read one by one. So for reading that code we need a pointer, and that pointer is known as a instruction pointer. Its size is 16-bit. That means the address of that location where the instruction has been stored, it is a 16-bit, and that address is stored in the instruction pointer. The next is execution unit. So this execution unit tells the BIU where to fetch instructions or data from, कहाँ से data fetch करना है, कहाँ से instruction fetch करना है. Next, decode that instruction after fetching and execute the instruction. So the functional parts of the execution unit are control circuitry or system, instruction decoder, and arithmetic logic unit. The control circuitry is used to perform various internal operations. A decoder in the EU translate instruction fetch from memory to generate different internal or external control signals that required performing the operation. This EU has a 16-bit ALU which can perform arithmetic and logical operations. Arithmetic operations such as addition, subtraction, division, multiplication, and logical operations such as AND, OR, XOR, increment, and decrement. Okay, so the functions of execution unit are to tell the BIU where to fetch the instructions or data from. Next is to decode the instruction, and last is to execute the instructions. So here we complete the basics of your 16-bit microprocessor that is known as 8086. I hope you understood all the points. Thank you.